Hello, in this presentation we're going to work a couple of examples of the difference of two squares. So let's just get started. So let's take what we have here, a plus b, quantity of a plus b, times the quantity of a minus b. We're going to use full. So you got a squared times negative ab, and we've got plus ab times minus b squared, right? And then we're just going to combine like terms. So these become 0, so you're left with a squared minus b squared. So like the other, when we did the perfect square trinomials, we worked the problem like we did here, and we came up with a formula. This is our formula. For the difference of squares. So now let's look at some examples like you might see on the homework or on a test. So let's say if you got x plus 6 times x minus 6. Well, you could always full it, and you would get x squared minus 6x plus 6x minus 36. And then that would give us x squared minus 36. Or if you've got your formula memorized that we just created, a squared minus b squared. So if you've got basically the same thing with a minus here and a plus here, you can use this. And really what this says is just take your first number and square it. So you got x squared. Then you're going to subtract your second number, which would be 6, right? You want to square 6 and you get 36. So we've got the same thing twice. Do another example. Say x minus 7 times x plus 7. Of course, you could full it, and you'd have x squared minus 7x plus 7x minus 49 gives you x squared minus 49. And, when you get really good at fulling, you notice they didn't take very long, right? But if you get this formula memorized and it becomes intuitive to use it, look how much quicker you can do this problem. X squared minus 49. And all I did is I took this number, squared it, took this number, squared it, and put a minus sign. Let's keep going. What if we had something like 2x minus y? These are some of the more complicated problems you'd see. Well, it's still going to be, our final answer is going to be in this form, right? A squared minus b squared. Obviously, you can fool it, but we're no longer fooling. You want to take our first number, square it. 2 squared is 4. X squared's x squared minus y squared. And this would even work the same if we had 3x minus 2y. That should have been a plus here. Sorry, let's back up. 2x plus y over 2x minus times 2x minus y. And then that would have given us this answer. I almost made a mistake, but I caught it. Here you've got 3x plus 2y times 3x minus 2y. So you want to do your a squared minus your b squared. So you want to take this first number and square it. 3 squared is 9. X squared's x squared. And then we're going to subtract for y squared. So I think you get the point. So all we're doing is we're taking, this. And to figure out the formula, we just forward it out, and we got a squared minus ab plus ab minus b squared over a squared minus b squared. And what I like to do is, instead of memorizing this, I try to memorize this process up here. Because if I know this, and I know that if I have an a plus b times an a minus b and the terms are the same, or the relative terms are the same, I can use this formula that I came up with. Because to me, you know, it's easier to remember. For me, it's easier to remember a process than a formula. If I remember this process, I can always get the formula. If I don't remember the process, for me, it's hard to, sometimes I can memorize the formula, sometimes I can't. If you remember the process and the steps, you're always going to remember this. If you just memorize this formula, you'll get some answers right on a test, but it won't be in your long-term memory. But that's our difference of two squares. Good luck with it.